Hello, Legacy Sabers, Marsh here. So today we're going to look at how do you write an equation of an absolute value function, either given information or from a graph. You're going to want a writing utensil and then the foldable that I gave you as well. So first, let's do a reminder. How do you decide how to draw a graph that you're given? So on this one in particular, so notice first thing we're going to want to do is determine all the transformations. So transformation here, 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 and here. So I'm going to make some notes here of what my graph has been done. Well, first thing I do notice is it's been reflected on the x-axis, right? Because that is the negative out front. It's been vertically stretched by 2. Okay. We've also moved it right 3 and down 1, right? So that's all of these things. So now from there, I have to change my parent table. So I got my parent table right here. And parent table, if you remember right, that's absolute value of just normal x. So that's -2, -1, 0, 1, and 2. And then that would be 2, 1, 0, 1, 2, right? Okay, so now I need to think, how are these things going to change this table? Well, right 3 is just going to add 3 to the x values, right? So I'm going to change my color here so we can see my adding. So I'm going to add 3 to all of my x's. Then I got to think through all of this stuff. Now, you want to reflect and stretch before you run and move up and down. So in this case, I have to reflect the values, which would mean I'm going to multiply by a -1. Okay. I'm also going to vertically stretch by 2, which means I'm going to multiply by a 2. And then I'm going to move down 1. So I'm going to subtract 1. Now, this new table is going to be quite interesting to figure out. So -2 plus 3 is 1. -1 plus 3 is 2. And then 3, 4, and 5, right? Now, let's think through this. 2 times -1 is -2. Times 2 is -4. Minus 1, -5. Okay. These -1, technically, you could just think of it as it's making a negative on everybody. So this, you could just tack negatives onto everybody if that helps your brain. Kind of helps mine a little bit. -1 times 2 is 2. Minus 1, that'd be -3. 0 minus 1, -1. -1 times 2 is -2. Minus 1, -3. -2 times 2 is -4. Minus 1, -5. This table right here is this functions table. So now let's graph. 1, -5. 2, -3. 3, -1. 4, -3. 5, -5. Now we'll connect some dots here. There's we go. Okay, done with that. Now let's figure out all of the key information about this graph. So my vertex first thing, that's the turning point, that is at 3, -1, it looks like. Intercepts, it looks like I only have 1, and it looks like it hit at -7, right? So that would be at 0, -7 for that intercept. This is a neither graph because it does not fold over the y-axis, and it definitely is not symmetric by the origin. Continuous, yes, definitely continuous, right? Boundedness. Now, can I draw a line above? Can I draw a line below? I can draw above, so I would say that this graph is bounded above. Increasing interval, he's increasing from -infinity, and he stops increasing at 3 on the x. Remember, increasing and decreasing intervals are always your x values. I am decreasing starting at 3 going towards infinity on the x. Remember x values. Minimum, none, right? No absolute, nor do I have any locals because there's no valleys. But I do have an absolute maximum at 3, -1. Okay, because that's the top of my hill. Domain, I am going from -infinity to infinity. Range, I start at the bottom at -infinity and I go all the way to -1, including -1 as well. Okay, so be careful when you're graphing this. The main thing that we're wanting to get past is this thing right here, is this transformation business on a table. And do you really need that transformation table? Not necessarily, because this guy's kind of linear. However, as we continue graphing even more functions in this class, you're going to find that that table is going to be super important. So we're going to want to do it even with easy functions so that way we learn how to use them now. Now, let's focus on the main thing of today. How do you write a function when you're given information? So I am told that this parent function is y equals absolute value of x. It's reflected across the x-axis. It's been compressed vertically by a factor of 3/4, and it's been shifted right 5 units. So, first thing, I'm going to kind of put some spots in. So I'm going to leave a hole here, put that x, leave a hole, because that's kind of where all the information could go, right? Well, I was told it's reflected about the x-axis, so that means I have to have a negative in the front, right? Then I'm told it's compressed vertically by a factor of 3/4. That would have to go in the front. Kind of like how that 2 went out in the front and we said it was stretched vertically or stretched vertically. And then I'm shifted right 5 units. Well, it won't be +5 on the inside though, right? Because it's flipped. So it'd be -5 on the inside. And notice, there's no shift up or down anywhere in this information. So I'm not going to have anything on the outside. So when I'm talking reflections, that's always the negative. Compression, stretching, any of that business vertically is always the number sitting in front of the absolute value. And then your right and your left information is always going to be inside the absolute value bars. Okay? Not hard by any means, but it's just kind of going backwards from what we're used to for right now. What if, though, we have a graph? So what I'm going to first do is I'm going to write down information about this graph. I want to first think, how did this vertex get there from 0, 0? Well, we definitely went right 1, right? We definitely went up 3. Okay, so right 1, up 3. Notice this is a gangsta V, so it's been flipped. So this is a reflection over x-axis. And then notice as well, this is a stretched V, because normally if it wasn't stretched, it'd be, they would have it would go from 1 to 1. That would be I guess, the slope of the lines, if you want to call it that. But if you notice, this is kind of a little different in this regard, in the regard of it's been stretched to 1, right? So on this one, I know it's been, let's erase that, vertically stretched by 2. Okay, so now I know all of the information about this graph. I got to write my function. So y equals, and I'm going to kind of put my template down here. So it is reflected, so we do have to have that negative sitting in front. They told me it's been vertically stretched by 2, so I'm going to put a 2 out front with that negative. Then they said I went right 1, so inside of the absolute value, where you'll find a horizontal move or shift, I'm going to go -1, because remember, it's absolute value. It's opposite when you are going left and right. And then I'm going up 3, so we're going to put a +3 on the outside. Now, let's say this stretch, you couldn't find it. There's another way to find that stretch as well. You could plug in everything else that you know. And then you would have to pick an ordered pair for your x and y, and then you could solve for that number as well. However, for absolute value, since they are technically still linear functions in a matter of speaking, we can just kind of look at the slope, quote unquote, rate of change of the lines, and that will give us the stretch value. And that's the end of this video. I will see you later, Sabers.